Hi everyone. In this video session we are going to look into next question in computer organization from the topic instructions pipelining. This question was asked in the year 2016 in set 2 for 2 marks. The question is, consider a 3 gigahertz processor with a 3-stage pipeline and stage latencies tau 1, tau 2 and tau 3 such that tau 1 is equals to 3 tau 2 by 4 equals to 2 tau 3. If the longest pipeline stage is split into 2 pipeline stages of equal latency, the new frequency is in gigahertz, ignoring delays in pipeline registers. So here we need to find out the frequency of the processor after the longest pipeline stage is split into 2 pipeline stages of equal latency. The frequency before the split is given to be 3 gigahertz. Now the key rule that would be applied here to solve this question is that the CPU clock cycle time period is equals to largest stage latencies. So first of all, let us find out the largest stage latencies before split. The stage latencies are given as tau 1, tau 2 and tau 3, and the relationship between these stage latencies are also given. So using these relationships, let us find out which one was the largest stage latencies before split. So the relations are given as, let us put them under the header before split. Before split, among these three, which one was largest? That is our target to find out. So the relationships given as tau 1 is equals to 3 tau 2 by 4 and tau 1 is equals to 2 tau 3, right? So these are the relationships, those are given. So from here, from the first relationship, we can see that tau 1 is 3/4 of tau 2. That means tau 2 is greater than tau 1. And from the second relationship, we can see tau 1 is twice of tau 3. That means tau 1 is greater than tau 3, right? So among these three, tau 2 is the largest stage latency and tau 3 is least stage latency. Now by rule, the CPU clock cycle time period is equals to largest stage latency. So the time period of the CPU before split is equals to tau 2. Now time period is equals to 1 by inverse of frequency, that is 1 by f, and frequency before split is given as 3 gigahertz. So 1 by 3 gigahertz. So from here we can see tau 2 is equals to 1 by 3 gigahertz. Now coming to the scenario after split. After split, the stage latencies would be equals to half of the largest stage latency. So we have found out the largest stage latency among tau 1, tau 2, tau 3 was tau 2. So tau 2 would be divided into 2 halves. Let us call this halves as tau 2 dash, and let other latencies be as it is because they would be untouched. Only the longest pipeline stage is divided into 2 halves, right? So after split, the stage latencies would be equals to, after split, the 4 stage latencies would be equals to tau 1, tau 2 dash. So tau 2 is divided into 2 halves. Let us call them as tau 2 dash, and tau 1 and tau 3 would be as it is. So these would be the 4 stage latencies after the split. Now we need to find out the largest stage latencies among these 4, right? So for this we would be using the relationship between this stage latencies. So we know tau 2 dash is half of tau 2. So this is one of the relationships. From here we can find out tau 2 in terms of tau 2 dash. So tau 2 is twice of tau 2 dash. Now from the earlier relationship we know that tau 1 is equals to 3 by 4 tau 2. Now replacing tau 2 by 2 tau 2 dash. So tau 1 would be equals to 3 by 4, and in place of tau 2 just put 2 into tau 2 dash. So 2 2s are 4. So tau 1 is equals to 3 by 2 tau 2 dash. From here we can see that tau 1 is equals to 3 by 2 tau 2 dash. That means tau 1 is greater than tau 2 dash, right? And from the relationship between tau 1 and tau 3, tau 1 is twice of tau 3, because these are the stage latencies which are untouched due to split. So the relationship between these two would be as it was before. So tau 1 is greater than tau 3. So among tau 2 dash, tau 1 and tau 3, tau 1 is largest. So the new CPU with 4 stages would have time period, let us represent it as t dash, same as tau 1, because that is the largest stage latency. Now we need to find out the frequency. Frequency here is equals to 1 by, so let it be f dash 1 by t dash, and that is equals to 1 by tau 1. So this is what we need to find out, the frequency of the new processor that is after split, and that is 1 by tau 1. Now the value of tau 1 can be found out by the relationship between tau 1 and tau 2, because we already know the value of tau 2 is equals to 1 by 3 gigahertz. So we can use the relationship between tau 1 and tau 2. Tau 1 and tau 2 relationship is tau 1 is equals to 3 by 4 tau 2. Now let us put the value of tau 2 here. Tau 2 is 1 by 3 gigahertz, right? So 3 and 3 gets cancelled out. So tau 1 is equals to 1 by 4 gigahertz. So if we put the value of tau 1 here in this formula, tau 1 is 1 by 4 gigahertz, 1 by 4 gigahertz. That is frequency is equals to, so we take 4 to the numerator, it would become 4 gigahertz. So the new frequency is equals to 4 gigahertz. So that would be the answer. So here the fill in the blanks would be filled with 4. Thanks for watching. Bye.